Hello everyone. My name is Anish Singhi and currently I am serving as the membership chairperson for SPE PDPU student chapter. A very warm welcome to all the people who have joined us in our very first session of Perspective, wherein we will be discussing about digitalization in oil and gas industry. SPE PDPU student chapter aims to provide each affiliate with opportunities for personal and professional development through amalgamation of events around the year, including distinguished lectures, workshops, seminars, and a plethora of contests with the sole purpose of bridging the gap between industry and academia. Perspective, our new initiative that is started by SPE PDPU student chapter, is yet another step towards bridging this gap. The live sessions of Perspective will consist of a one-on-one interview with a renowned official who is associated with SPE International. And before each session, a portal will be opened for everyone to submit their questions on the decided topic. Therefore, I would like to urge all our viewers to follow us on our social media platforms so that you don't miss out on this great opportunity for our future sessions. Now, coming to today's topic, the industry worldwide has been swayed by the digitalization wave, with investments targeting improvements in market performance and competitiveness. The oil and gas industry has holistically embarked on a digital transformation which will impact the entire petroleum engineering domain now more than ever. And that is the reason I feel very blessed to have with us today Mr. Saeed Al Mubarak. Having served the petroleum industry for more than 30 years, Saeed sir has been a noteworthy leader in the area of intelligent energy. You may know him as the chairperson of DETS SPE or Digital Energy Technical Section, but he has also served in various capacities that span across local and international levels, from technical to administrative levels, and from simple roles to holding leadership roles. His contributions to the area of intelligent energy and innovation are recognized by many auspicious awards, with the latest being SPE Distinguished Service Award. He is recognized and technical and inspirational author and a speaker. And I cannot stress this more. We could not have found any better person than Mr. Saeed to assist us in today's session. So I would like to introduce you to Mr. Saeed, and sir, the floor is to you.
Thank you, Anish, for the great introduction, and thank you to your chapter for inviting me. And welcome all to a presentation that will be more of entertaining and educational. And at the end of the presentation, we'll entertain as well. You know, it will be more of Q&A. Well, I chose the title more of Challenge Paradigm, Make Impact. And this is not only that fits with digitalization, it fits various aspects of our life. And I have a question for you, although I don't see the participants, but I know they have some sort of an idea on how many people have lived on Earth. The intention here is not really to question your information, but just to think about how many people have lived on Earth. And the second question is for our participants from India. What's the population of India? I know you have answers. Unfortunately, the technology is limited. I don't, unless it's a poll. I don't hear your answers, but definitely you know the answer. But out of those who lived on Earth and who live in India right now, who remains? And this is a title of one of my articles. And the answer is basically those who left legacies. And you see here some sort of examples of those who remain. And I know you admire many scientists and you have ideas about what they've done and what they left basically as legacies. Be it Einstein, be it Gandhi, be it Steve Jobs and others. But the question is, what did they really have that you don't have? I mean, think about it for a second and just see what they really had that we do not have. And I don't see anything they have extra than anybody of you. So they have one brain, you have one brain. You have two legs, you have two legs. But it has to be something out of the traits they had of their personalities, other than their bodies, their dedication, their focus, and their basically efforts to do something that's different and maybe to add something to this world that remains. And definitely all the aspects of that they brought to us was more of cumulative knowledge from different people. It's not really them by themselves. They had their knowledge, they passed it over, others built on that knowledge. So it's the cumulative efforts that we had and a cumulative knowledge that we had from them and others as well. People we haven't seen, people we haven't met from different places and different times. And this is what comes basically the power of integrating differences. People are different, ideas are different. In fact, even our bodies contains parts that consist of different, basically, just like the hand here. I mean, we have 4 fingers and 1 thumb, and in fact, they function very well because of one thing, because they are different. And if you go, even teeth, I mean, you see them different teeth, different sizes, different shades, different locations for one reason. And this is the wisdom of the creation itself, of the creator, where basically these differences are integrated to function and function very well. And this basically goes into a society, into a corporate, into a school, into any sector of the industries. Now, things really evolve, and this is only one example, not only with the petroleum industry, even in the other industries, any industry. And for here is just like an example of Apple when it started. And if you look at the left, right, the top corner, basically, it's more of a wooden box. And today you have almost a computer the size of your hand in your hand, where you can communicate. It's a camera at the same time. And maybe some of you are watching the presentation through their mobiles. So you see, things evolved, and this is exactly the same in any other industry, including the oil and gas. And if you look at the first rig here and to the left side, it's a wooden rig. While in the right side, you see how basically technologies evolved through time. And definitely those who contributed to the advancement of these technologies are not one. There are many. And they contributed. Maybe we know their names, maybe we don't know their names, but definitely we see results. And these are the results. And when it comes to other things that are very relevant to the basically petroleum engineers, when we started, we drilled vertical wells, then horizontal wells, then multilateral wells, and then multilateral wells with downhole valves. This is more of the advancements, not only in the completion or the well types, but even in the completion, and there are more sophisticated even equipment, be it subsurface and surface. This takes us all, to things, few points that you have to remember. They're more of tips. These technologies, when you use them, they have to fit for a purpose technology. It's not really we go and seek technologies and use them just for the sake of it. They have to be for an objective that we already know. Definitely technology is different and varies in size and shapes and functions. So there is no one size that fits all. And technology that fits a certain reservoir, certain application, certain wells might not fit other wells. So we have to make sure and to keep in mind that there is no one size that fits all. Definitely, for any technology, we have to keep in mind the short-term and the long-term objectives, be it for the technology itself, or be it for its application and maintenance, or be it for the application and use of it within the reservoir itself. And every technology has capabilities, and definitely there are uncertainties associated with it. And now people talk about digitalization, components of it, artificial intelligence, maybe machine learning, and others. And these are basically the four tips that I would recommend for everyone to look at and think about before even applying a technology. Now, when it comes to the digital world, there are four enablers, in my opinion, and one of them is the technology that we given basically the tips for. And if you look at the right side, right side, there are spheres, and every sphere is representation of the investment size. So when you invest in technologies, more of technologies, the investment will be really huge, and the size of the sphere. Business environment and changing the structure of organizations or constructing a new one, another investment, but it is a less size, a smaller size of investment. Then you go to optimization processes, and definitely that's something that evolves over time. And it's a continuous improvement of optimization, of optimization of processes that are existing, or maybe new one based on the technology that you introduce to your basically domain. But in all of these, there are people, and definitely people are components in every single endeavor that a company or an organization or an academic center, pursue. Now, if you look at it from different perspective, and you see the x-axis where it represents the value, you see the highest value comes from people. People are the ones who are inventing technologies, maybe to meet a challenge or to improve a situation. They're the ones who are aware of its capabilities and maybe explore its uncertainties or the uncertainties associated with it. They're the one making the environment, and it's an ecosystem anyway that people are the most important part of it. They're the ones creating the optimization processes, coming up with ideas, new ideas, innovative ideas to optimize the whole sector, be it technologies, environment, and the processes themselves. Now, looking at the aspect of digitalization, we started with technologies, and just like it demonstrated, it is the biggest investment or one of the big investment in any digitalization endeavor. Now, you see the path of maximum value, it comes out of technologies, but if you have technologies by themselves, they're only tools. You have to have knowledge management, and where basically where to store knowledge, how to basically preserve that knowledge, share that knowledge, and exchange it with others to in a way that's structured and standardized. Then, if you have the knowledge and you have the data, the information, you'll be able to visualize it, monitor it, and respond as well. That's more of informed operation. Then you go into predictive operations. If you have all the capabilities, be it AI, be it simulation models that are conventional one, numerical, physical-based, data-based, and the optimum is basically to do optimization in all the other layers, be it in the optimization in the technologies and how you manage even knowledge itself, and in your operation, and in your even predictive models themselves. So optimization is more of the optimum, the maximum value that you will attain from all of the basically the ingredients of digitalization. And now I posted once a poll in LinkedIn, and most people agreed with this basically segmentation, and they see most of the value coming from informed and predictive operations. Now, where do we see value out of these basically? It's in field and reservoir management, where you can manage things, more in real time. And it depends how you define real time, but we can discuss that in the QA session. You can do plant management and control, optimization of a field or a well, continuous monitoring, and others as well. Now, What industry leaders say about digitalization or intelligent oil fields or digital oil fields? Most of the majors indicate that they foresee great value in, in that business modality. Maybe the assessment of the value is a little bit harder from one function to another, from a company to another, based on their overriding objectives, but definitely they see value of it. Now, we have to be really ambitious when it comes to our work, but we must be also realistic. And today, it's not like any other day. It's basically we have wells that are very old, and these are more of realities. Fields, most of the fields are maturing. You barely hear new discoveries, although they are, but they're not really as many. Technologies is evolving, and some of them are old, maybe obsolete, and companies are implementing and trial testing new technologies. And many environmental concerns are basically surfacing out with CO2 and basically the whole environment and ecosystem. Now, what comes with aging wells, maturing fields, is production losses and resources incentives. You need to maintain these old assets and extensive surveillance just to make sure is everything safe and running as you expect. Intensive maintenance for technologies and facilities. Higher investment when it comes to the implementation of contracts and maintenance and other things, and more concerns. So you can look at this as opportunities. You can look at them as challenges as well. And this is where the skills and tools can be used basically to minimize the challenges or even eliminate them and produce more value to the organization. Now, if I take you to a journey to the field, and this is more of a virtual, and I wish that everybody has a chance to go to a field where they see the well site, they see the surface equipment that are basically, and the instrumentation required to make a well connected to the headquarters where people can control that those valves. They see the measurement and they control the chokes. And if there is an ESP, basically on a well, they can monitor what goes on there, and they can optimize or at least predict what goes on. BDHMS, this is more of sensors that are subsurface for pressure and temperature. And there are, just like we stated earlier, the smart wells that consist of downhole valves with multiple choke settings. Now, if I take you a little bit deeper to the hidden world, and this is basically more of subsurface, for multilateral wells with the three legs or three branches or three laterals, basically they go into, let's say, reservoir A, B, and C. Every single reservoir or even a segment of a reservoir has its own properties. And these properties might be different, and they're definitely different in a heterogeneous reservoir or in different reservoir layers. Now, if this completion that has basically three laterals are equipped with downhole valves, this is the picture on your right-hand side, with different choke settings. Some of them are 6, some of them 8, 12, and some of them are percentage-wise, but they're more of a sliding sleeve that you change basically the area of flow. So you're not only taking care of all the properties and the differences between the boxes there, the reservoirs, and you basically have another basically things that can change and variable, that's the choke setting. Plus A, B, and C, these laterals have different sensors as well, and every sensor measures certain aspects. These are the data that can be used to monitor and maybe to optimize, but definitely there has to be some sort of workflows and procedures to attain these data and to have them accurate, stored in a database, in a standard way for it to be used by the expert or a system to bring value and basically to meet certain objectives that the operator sets. Now, what's more than in the technology side, we have communication infrastructure. I mean, for you to get the data in real time, a well has to be connected either wireless or wired. Then if it is wired, is it copper wire? Is it a fiber optics? And if it is wireless, is it a shortwave? Is it UHF? Is it satellite versus, let's say, mostly used VSAT? And definitely there are details on the amount of data, the granularity of data, how often we transmit. Is it a batch? Is it real time? All of this is basically has an investment associated with it. So it's not really, although the technology is available, but there might be, affected, the choice might be affected by the investment side that's basically put for the project itself. Now, just fundamentals, and we have to remember always these fundamentals because we use them even in a conventional field that is not connected. We go into acquisition and learning, and we manage the data, we do analysis, and definitely based on those analysis, we make decisions. And if feasible and everything is okay, we go and implement an action. And we go through this cycle. Now, with the assessment of technologies and availability of quicker, basically, and more robust technologies, we can reduce this cycle and make it shorter for certain processes. But certain processes would always take time. Now, there is a video that I'd like you to watch, and it has the music in it. It's just to remind you on the importance of fundamentals, because people sometimes tend to lose touch of basically the fundamentals that they've learned because they get attached with technologies.
Whoa, that's not good.
Oh, I don't need this. I'm already late.
Somebody will come. Anybody out there?
Do you have a phone?
No. Sorry. Somebody! Hello? There are 2 people stuck on an escalator and we need help. Now, would somebody please do something? I don't believe this. You gotta be kidding me.
I'm gonna cry.
Well, there's not enough left to do. That's it.
I believe you've got the message out of this clip, and definitely technologies are there to help us, assist us, but not to let us forget about the fundamentals and how we can use them and capitalize on them, even if technology is not there. Now, always remember, and these are for the young generation and even for me, great minds discuss ideas, average minds discuss events, small minds discuss people. And I'm sure we're discussing ideas here, and the question will be about ideas. And most of basically those who we shown their picture brought ideas, and this is why they remain. Now, another thing that need to take care of, and definitely there is a balance of wheel of life. This wheel of life changes with time, so you get more focus when you get a little bit older. Your energy level is high as basically students in universities. Health, your commitments, your engagements are less, and definitely you can do much better and more things than older people can. But definitely the older people can do other things in a much and more efficient way because they gained knowledge that they can share with you, and you can capitalize on that knowledge to make the best value out of it. And by this, I'm done with the presentation, and this is basically the time for the Q&A. And Anish, it's your turn. I wish you could talk. By the way, I could see the ones who give the questions, but maybe this is a limitation of the technology.
Yes, and that was a really good presentation, and I hope all our viewers could understand the meaning of that last video, just as I did. And really, it helped us to understand what should we focus on as students. Yes, sir. So thank you for sharing that PPT. And yes, now we'll be moving forward to the Q&A round. So actually, you have covered almost all broadly all aspects of digitization, but still, for our viewers, I would like to ask a very basic question, and I think you can answer in just few lines. What is the role of digitalization in the energy sector? That is the first question.
Before we go into answering what's the role of digitalization, we have to define what digitalization is. And people have different, basically, definition of what digitalization is. Some people will refer to it as only technologies, and maybe this is what maybe the students and the questions, they would be more about technologies, I think. But it's not really technology. As we described in the tips at the beginning, technology is only one component. But knowing the company and the structure of the company and how it operates, knowing the processes within the company, and how you can use the best technologies to improve a current situation or to resolve or solve some sort of the challenges. Is it really digitalization when we use technologies? Yes. It's at least what's referred by the industry. It's having all the technologies that are necessary to optimize, and they're related usually to real time. But anyway, so it's having the appropriate technologies to basically improve a current situation using a workflow, using basically workflows that are either existing, so you basically improve the existing ones, or you come up with the new workflows that suits an objective, be it optimization, be it predictive maintenance, or be it monitoring and visualization.
Yes, sir. Very right, sir. And yes.
But again, there is no unique definition of what digitalization is.
Yes, sir. So maybe our next question can clear any doubts in a viewer's mind. So you have had you had an extensive career of more than 30 years. So there have been many transformations in the oil and gas industry. So can you just mention and give an example as of all the transformations that happened of digitizing the operations in each sector of our value chain, oil and gas value chain, like starting from the exploration and then to utilization and all the aspects of our industry, how we have changed the digitization aspect of our industry?
Well, people started with digitizing first. So all the information that they had in different records, they digitize them, so they have them ready to be accessible through different tools, even Excel. Okay, and then that data was used basically to be visualized through different applications, be it vendor, basically developed by vendors or developed in-house, or by even primitive tools and applications that exist in every computer. And then when it comes to the production engineering, is a bit different, where basically they have subsurface and surface technologies And maybe this is a focus that we at least we start with. Subsurface technologies and surface technologies. It's a lot. It's basically the component is technologies now. Subsurface technologies, we've mentioned one, for instance, the smart completions and ICVs, which has basically sets of subsurface technologies, just like multi-phase flow meters and RTUs and more of IT infrastructure in the surface, plus the communication to have the data and control, within the control rooms within in the plant, and have that connected to the headquarters of a company. Now, if you go to the production engineering, they said their objectives basically to operate these wells at a certain rate. I mean, it depends on the objective now. So they monitor all the rates, they monitor all the wells production, they see what they're doing, and if they have the technologies, be it subsurface or surface, they monitor the health of these technologies, and they see how they operate, and if they have automation, then basically they basically control from control rooms. If they don't, then they go physically to the wells to maintain. That reduced basically the time to figure out which wells are failing or tripping, or if you have real-time connections to the field. Now you talk about the whole energy sector. And this is more of the production engineering. For reservoir management is a bigger cycle, basically, where they see how reservoirs, they monitor the reservoir, and they see more of how the pressure, let's say, propagates from, if they have an injection system, how the pressure basically propagates in the reservoir, and pressures are leading indicators of, let's say, water encroachment within an area. And definitely they monitor the health of the reservoir, the health of the wells. So every entity has its own objectives that might be similar to another entity or might be different. And sometimes entities have different or competing objectives as well, and they have to communicate with each other to more of agree on what the strategy is. I don't know if you answered. I mean, that's more of a very detailed question that needs a session by itself.
Yeah, yes, I understand this. But actually, I'm glad that you brought up the point of reservoir management. So, as a student, I'm also very interested in reservoir engineering and reservoir management projects. So now, as a student, I learned all the basics. I know my fundamentals. So, how can I be prepared for now the currently what digitization is there in the industry? The industry uses high-tech softwares that students can't get their hands on very easily. So you mentioned that all the digitization processes started from Excel, and these are small softwares that we can work on. So can you give an example of how can students can use this basic softwares to apply their fundamentals and actually get an insight into industry workflows so that they will be better ready when they graduate and join the workforce?
Well, reading articles and what basically others have done is the first thing I would do. I mean, people have tried basically and implemented different technologies, not only that are. I mean, again, we have to define what digitalization is, but they have defined practices, they implemented technologies that are associated with the digitalization thing, and now. If we read all these basically publications about people and what they've faced as challenges, what they have resolved, what optimization they've done, and what value they attained. Let's go for an example with artificial lift optimization. Any type of artificial lift optimization, be it an ESP, rod sucker bombs, and these things. There are many applications, let's say, of machine learning to monitor what's basically, to learn what these machines are doing. It's just like any other machine learning. applications at surface, be it turbines and others, then they create some sort of a behavior to these systems to predict when they would fail, to predict when they need maintenance. And definitely there are many companies who capitalize on these technologies to optimize the production. Now, when it comes to AI and machine learning and the prediction of failures of rotary equipment, it might not be very popular, although it's a good application. But there are applications of that are real time and optimization of basically production of a total field, where they know exactly where failures are. They have triggers which wells need to be, let's say, switched on instead of, I mean, they trip, for instance. So it minimizes the time for operators to go and attend these wells to make them operate again. These are in the operation side. For you in the reservoir management, again, reservoir management, it depends on the surveillance, basically activities that you do and how many, let's assume how many pressure points you get subsurface or surface. And if you know basically well modeling, then you can even recalculate subsurface pressures based on surface information, surface data. And definitely in recalculation of, let's say, shut and bottom hole pressures, you can create an isobaric map for the field that can be dynamic, depending on the gauges that provides more of real time at surface. So you don't have to have subsurface equipment if you don't have it. So in creating those maps, you can come up with understanding of how the field is performing, how wells are performing against the strategy that you're basically implementing. So what do you expect from them versus what they're doing, and what you need basically to adjust to achieve your objectives that are more of short term. But companies have different short-term objectives. Some companies have basically, they want to just sustain production at a certain rate. So their strategy is more of lean, and they know, and their monitoring basic program as not intensive as those who wants to maximize the production. So maximizing the production, they look at every single drop that they can add from every single well, and be it an instrumented well or not is a bit different. And even in the monitoring frequency is different from those who want only to sustain production and they know exactly how their wells perform. Again, for the reservoir itself, there are people who wants to, for people who are maximizing production, maybe it's less important. Basically, maximizing recovery is less important to them. People who are basically, their ultimate objective or their long-term objective is to maximize recovery, they usually tend to monitor their wells very closely. They don't go below bubble point, for instance, in certain areas if they could. They operate their even equipment at their within their efficiency curves, and they make sure they sustain basically good health of the reservoir, the wells, and the equipment. It's different objective from one operator to another. But definitely reading previous experiences and exchanging with people who have knowledge will bring greater value to everyone.
Yes, sir. Okay, yeah. All our student viewers can surely act on that, yes. And so, sir, talking about the value chain, what are the new technologies that are being invented, or yes, the digitization, what is happening in the HSE sector, uh, health, safety, and environment? What are the new?
Well, there are lots of technologies when it comes to the HSE, although it's not my territory. But the sensors within the field, let's say an operation, definitely the safety of the crew is really important. Be it to put a sensor for gas, or in a plant, or even within a well during an operation, for instance, and drilling and others. And there are many sensors and that basically and alarms uh, that are basically dedicated to, let's say, gas. And there are others that are dedicated to the safety of the well itself and the well integrity. So high pressure, low pressure, be it during normal production or during even operation, let's say drilling and working over basically the well, or even conducting a wireline job.
Yes, sir. So, yes, we have a question from the audience, and how the tools that you just mentioned in like big data and data science how can we apply those in drilling optimizations and production and operations?
Well, there are many tools and there are many companies that basically are promoting, utilization of AI and big data analytics on the available data. And definitely, if you have data that is accessible and you have historical data from from the same area or the same application, that will be a plus for you basically, or for the operator to get basically some sort of an image and expectation of what might go on for that thing, be it a machine, or be it a process, or be it even an a will modeling. Uh, but data has to be really available. Enough data, historical data has to be there. So the population of data. And one more important thing about data, it has to be you have to be confident that the data is accurate. So the process of cleaning that data that we call big data, the process of cleaning, cleansing, and making it ready to be used for an artificial model or any analysis is a necessity. And in fact, even for normal analysis, just a conventional way. But definitely for AI-based or data-driven models, the data, accuracy has a big weight on basically creating a model that's more of a trustworthy. Uh, so knowledge about the field itself and knowledge about the data and its quality is really important. And the use of these data, regardless where they are, be it subsurface, surface, facilities, I think they're endless. But again, uh, AI, machine learning, big data analytics are tools, and they have to be a fit for purpose. So if you have a technology that's very convenient and is available and it produces basically the results and shows you the of the analysis that you're okay with, use it. If AI has a greater potential, you may try it and see the difference. But you will go through an assessment of basically which one is better and which one is faster. So you will more of judge based on uh, the differentiators between the two tools.
Yes, sir. Yeah, so we have another question on building on that. So AI and machine learning, can they really automate these business operations given the regulatory compliance requirements are met? And yes, we know that the purpose is being met with these technologies. Will they be ever able to fully automate these operations?
Well, again, we don't have to exaggerate the capabilities of a tool. whatever we call it, be it AI or be it even a completion. So physical or data-driven, we should know exactly its capabilities, and that doesn't really deprive us from using it to examine its potential. Now, AI again is just a tool, and if it brings value to you have to try it basically. And again, most of the question will come up with AI and machine learning. Automation exists in the industry long ago without even talking about AI. So it depends on really the process of it, maybe enhancing certain steps of the process may rely on AI, or maybe better if we capitalize on AI. But we have to be really, really selective. Now, if you go to a system that's already automated today, and let's say 10 years ago, cars basically, many components in the cars were manufactured in a production line that's very automated.
Yes.
Now, when it comes to processes within the oil industry, there are processes that can be segments of a processes, maybe that has lots of data and different data that we can use maybe AI to expedite the outcome of it. Why not?
Yes.
It's just a tool of and a component maybe within a process that we can capitalize on whenever it's basically it gives value.
Yeah. Thank you for answering that, sir. So again, another question is to sector centric. So the question is really I found very interesting, and I would like to know more about it. So here it goes. We are facing many treacherous blowout incidents, and we know that digital transformation actually can suitably prevent most risks, including blowouts. So is there any a plan of SPE or any regulatory body to implement a protocol for industries across to mandatorily use digital interventions, especially in brown fields as well as in active green fields?
Well, there are many failures that happen basically in history of the industry, or any industry. Some of them are human errors, some of them are technological errors. So technologies, and definitely if we have the right technologies that can detect things or predict things that will happen, then it's more of it gives an alarm, so at least we get ready, things might happen. But many of these technologies are sensors, let's say in operation side, they'll give you some sort of an indication that may be a leading indicator to consequences, but some of them will give you just like it's just happened. So if a failure happens, it's just a failure happened. So it depends on the knowledge that you have. If you have, let's say, some equipment that you have mass of them installed and they have some sort of repetitive function, then that's a case where you can use AI or machine learning to predict. But for cases that are really new and you have limited data and history, that's really very hard to predict. So we will rely on a human and experience and intelligence, plus the devices that will give you some sort of an instantaneous alert. Let me give you an example here that's out of the oil and gas industry. Let's say COVID-19. Definitely, there are many applications of AI. People have applied it on, let's say, predicting how it spreads, even in the deciding what medication might be a good medication for it.
Tracking.
But definitely, yeah. So where it's gonna go? But definitely, they're not really as precise as predicting something that happened earlier in different places, different times, and we have lots of data, and we know exactly where the end is. This one is new. Even if you speak to a domain expert, a specialist, uh, his specialty in this domain is relatively new, and the specialists themselves have different opinions. Data is different and it's sporadic, but some of them are not conclusive. So that's a bit harder case. But for cases that are more of, let's say, X-rays, for instance, to determine if people have cancers, or they have lots of cases in the medical industry, and in fact, the common article or example that you will see in utilization of AI is basically the capabilities of AI to predict cancer much better than, let's say, a physician, or quicker. Because we have lots of data, we have lots of cases. Not only this, these cases are shared among the industry, the medical industry. So they're very transparent when it comes to it. The cases are maybe put in one single model, maybe hundred thousands of them. And this is why the model came to be in a good shape, where it does not only diagnose, but it predicts what might happen to that situation or the other. In our industry, it's very conservative industry. The basically, even if we installed, let's say, an equipment, thousands of them in different fields in the world, they belong to different companies. They are operated differently. Companies and operators have different strategies and operation, basically operating them in a different way. And the thing that differentiates us between the medical example and us, we don't share and we don't exchange, and almost everything is confidential. So unless one company has a big population of a certain equipment, I doubt the industry can basically create that model that fits all. So it's more than the technology itself. It's beyond. I mean, the example of the X-ray maybe demonstrate what goes on other than the technology itself. But the technology has proven that its capabilities anyway.
Yes, sir. So, relating to your answer, one industry professional has asked the question: every well and every field is unique and as you mentioned, sometimes if this analogy fails, then how to predict the reality? What to do in those cases?
Well, if we go with analogy, even in a conventional way of running our business. Now, if we have lots of data about wells and their performance, which is not the case. Lots of data means from different places, different areas, different reservoirs, different layers, different crude type, different completions. Then you have a population of data that can be used. If you don't have it, basically, all you do is basically you use your limited data, and I hope the data is accurate. And let's assume that it's accurate. And then with the limited history, so it depends on how long the history is and how many oil wells or gas wells, even water wells are there with a similar condition in a similar reservoir or similar behavior. And we have to associate this with uncertainties. So it's more of giving you a best trend or a best behavior rather than an absolute truth, because you don't know it. Now, if you go to the oil and gas, or let's say subsurface, at surface, we know the technologies and we go and check them. And in fact, we physically, we can go and check them. And And we can create the models for these machines, be it a plant or multiple machines that are similar or different. Uh, Still, we associate, and we have access to the data, still, we associate some uncertainties within the results and the expectation and prediction cases of be it failure or tripping or even good performance. Now, if you go to the reservoir, any reservoir, all you have access to is a 6-inch hole well within the reservoir. Let's say for a section of it, and maybe the whole reservoir. But it's a 6-inch hole, and maybe you have another 6-inch hole 100 meter, let's say in certain countries, but maybe 500 meters or 1 kilometer in different countries. Now, the things you know about the reservoir is far less than what you don't know. So even if you don't use AI or machine learning, the conventional way of doing business, we correlate, interpolate, and we make our best judgment in how the reservoir is. Is it really the reality of reservoir itself? It's probably not. And this is with a homogeneous reservoir, and you will not be able to create an image of the reservoir in a model. Now, if you go to a heterogeneous reservoir with lots of streaks, fractures, faults, it's a bit different here. And this is why you will see multiple models, multiple scenarios that they run just to make sure they're covering all the scenarios and possibility. Now, if you go to unconventional, it's even more complicated. So there isn't an actual reflection of how the reservoir looks like, or how the well will basically 100%, match. There might be not a 100% match, and again, what you know is far less than what you don't know, and the best model is basically the model that gives you the best results that are acceptable, and you can base your plan on. And hopefully, it meets the objectives, and the predictions are within the uncertainties that you accept.
Yes, sir. True. Yes, sir. Well said, sir. Yes, sir. So our next question is now we will move towards the managerial aspects. So our next question is like that. So the question is leftover assets downhole are ultimately detrimental and they are really money wasted. So, and we know that digital intervention can suitably determine not only the value of assets and it can also ensure maximum recovery. So, do you actually believe, do you agree that digital intervention towards this and completion services and in this sector can actually is up to mark currently in the industry? I'll reframe the question, sir. We are not using a suitable digital intervention towards assessing the value of assets that are lost downhole in leftover assets downhole. That yes. So is this
So
true?
the meaning of digital intervention, it's I don't know. It's just like regular operations. Or what exactly is digital intervention? So that's not really clear. But
Yeah.
if you say, let's, I don't know if I'm right or wrong, but let's say if I have an artificial lift system that needs a rig to pull the completion, and I have another one with the same properties, same capacities, and same power, and maybe a better one that I can deploy with no rig. And definitely, I'll go with the one with no rig. It's not only to install, even to pull whenever a failure happens. It's easier, cheaper, and more convenient to operator rather than bringing basically rigs and barges, and if it is offshore, just to pull a completion. So that's more
Yeah.
of
Yes.
what I feel like. And there are also gauges that are retrievable. They're not really permanent, but that's a different discussion. Basically, which one is better? A permanent that's basically wired to subsurface, or maybe using electromagnetics or some sort of communication aspect. Then you go into power generation issues, and where it's going to get its power if it's wireless, for instance.
Yes.
If it is retrievable, it will have a battery, and battery has a lifespan.
Yes.
So should I put one it's digital, but it's wired, and I have another one that's wireless that I need to retrieve, let's say, every now and then. So it depends on the philosophy and the economics and the preference of an operator. Some people would say, I will use one for a lifetime of the well. It has to be wired. Some of them will not mind going with a wire line and pull the retrievable gauge and change the batteries. I mean, for let's say a shallow well, it's different from a deep well, and so on. So there is no one unique answer for the question, as the question is, and the question might need some clarification.
Okay, sir. So, okay. Yes, sir. So moving on. Today, most businesses understand the need of digital transformation. So, what is the key, or what is the most important enabler for digital transformation?
You.
The students?
Yeah, people, and this
yes.
basically it's you.
Yes.
So we start from the basics, basically. I mean, we see the value based on one of the slides that shows basically the spheres. The highest value comes from people. People, they can innovate and come up with the processes, even with the limited implementation of technologies. Let's assume that you have a field and you have your own process that's conventional process, whatever the process is, be it constructing of a well model, nodal analysis. And that takes time, let's say, using PipeSim, Prosper, and others, okay? And maybe you know how to construct a well model, and it takes an expert, let's say, if the data is available from minutes to hours to have a good well model. Now, assume that I have hundreds of wells, and I need to construct basically the models for all the wells. I have the data, I have the application, that's technology, I have the data, that's requirement, and the database is okay, data is accurate, but I need to generate the models. If you go conventional, you go construct one by one, and that will take time. And if you can automate it using your basic knowledge within the capabilities within the system itself, even using Excel and some Visual Basic easy program, you can automate the whole thing where you can generate the models, and instead of, let's say, 1 hour, it can be in minutes. And you can generate all the models for all the wells, and the process itself can alert you to the models that have some sort of questionable results, or maybe need some sort of the engineer verification for a reason or another. That's an easy thing. It shouldn't take much time. It shouldn't take even a great efforts. Using whatever you have. You don't have to install any gauge. You don't have, just use the data that's available, assuming that data is available to start with. And check the data, use the model, and automate it. That's an easy thing.
Okay.
So it's people.
Yes, sir.
Workflows of existing technologies. Then there might be some sort of changing within the organization, and people refer to change management where basically management promote these aspects of coming up with new workflows, capitalizing on data, and they have to come up with more of incentive programs, roles and responsibilities, and other things. That's more within the organization. So all these capabilities, to even companies that have no access to real-time data, they still can have some sort of optimization. And I wouldn't say more of evolution and the thing. It's basically natural progression of processes and utilization of data. So just go and use them, and it's a continuous process of improvement. And if you have technologies, then it's a bit different. What kind of technologies? Is it surface or subsurface? If it is surface technologies, again, constructing of these models and making them really real time, you can do that. You can, if you have a model that's validated, then you can even estimate an actual growth rate. If you have an extra component of technology, let's say water meter, then you can estimate how much oil real time. So it depends on, start from people, make sure they know what the company is, what the objective of the company, short and long term, what kind of processes that exist, what they have access to data, and get them access to data, get them to know, to communicate with each other, to see what challenges, what areas, rank these challenges, what challenges that can be basically tackled immediately, which ones are harder. Get the domain knowledge experts to share their knowledge within. So it's more sharing and exchange. And definitely you go to the hand slide where basically everyone has his own capabilities or her own capabilities. Everyone is unique in the knowledge they've got and the strength they possess. So all they need is basically to integrate the differences they have, because if they're all the same, they might be useless. You have only one is enough. But if they're different, that's basically what bring power, to bring people with different minds, maybe different organizations and entities, to come up and join efforts. And this is how you come up with, you bring power basically to the team.
Yes.
Again, they have to work for
Together.
one objective.
Yes, but assuming that there are teams and the people are coming up with new technologies, now in the current scenario, are the companies going to monetize or going to capitalize these projects, invest in new technologies, or they're going with the conventional or the existing workflows?
Well, there is no one answer here. I mean, companies who are thirsty for technologies, they will they have basically it's embedded within their structure that they trial technologies that fit the purpose, and they basically have their own budgets and teams to trial test technologies, and they want to use technologies for the value they bring, and they can afford to. There are companies that target certain technologies, but not other ones. So it depends. It depends. But are we going really fully automized? It depends on many other factors, be it security, transparency, communication, even politics can be part of the thing. So we can't generalize it, because there are many processes. Certain processes can be.
Yes, sir, but in current scenario with the cash flows coming to a halt, and the companies might have to restructure the budgets for new technologies. Will that happen, or the that companies will still be trying to apply these new technologies to their fields?
Well, I don't think companies just want to try technologies for the sake of the technologies themselves. If they bring
Yeah.
value, they'll use them whenever. It was in the past, and it will be in the future. So when technology is applicable and they see value of it, definitely they'll bring it to the stage. They test it. If it's approved, then they will use it. So um, I feel like if something either brings value today, will use it, and it has to be proven. I don't know if I answer your question,
Yeah, yes,
by
sir.
the
Yeah,
way.
yes, sir. You did, sir. Actually, yes, because yeah, I wanted just to, as a student, I also wanted to know: is there any future, or is there any sense in trying to build these new technologies? Yes, and by your answer,
No,
I
but
think
what kind? We have to be clear. What kind of technology that
yes, so maybe of
that the question?
fully digitizing the oil field, completely remote digitalized oil field. Yes, maybe in that sense.
No, but well, again, I mean, it's just like I mentioned. When it comes
Yes,
to
yes,
digitalization of the whole field, uh, uh, it's just like having an ICU and all the wards in the hospital, more of ICUs, intensive care
yes,
units.
sir. Yes,
Uh,
sir.
this cannot be done
Yeah.
because there are different priorities. Which wells you need to monitor real time, which well you need to invest a big an investment in it for you to monitor. Let me give you one example here in the from basically the again medical industry. The ICU is more of strategic in most of the big hospitals. So if someone tells you that do I have to have an ICU? Last year we did not have any critical case. Is it a waste of investment? Somebody will say yes. Somebody might say no. It's a strategic thing. Maybe one day we'll use it. Now, when it comes to the ICU, we know exactly why it is there. It's for people who are really sick, and it's important to save their lives and give them the required care and attention. Now, when it comes to oil fields, it depends which the wells might be two types. One of them is very prolific. It produces, let's say, high rate, and other wells that produce a very low rate, and they might die. The one well that produce, let's say, 10,000 barrels is equivalent maybe to, let's say, 20 wells of the low production wells, the sick ones. Which one you would like to monitor real time and ensure that it's running? The low production wells or the highest production rate well? So
Yes.
because if you lose one well, that's 10,000.
Yeah.
You may be okay with it, but if you have too many wells that are operating at low rate, but the philosophy is different there. The healthy one, some people would say, no, I'll monitor the healthy well,
Yes.
not like the ICU in the hospital. And I have too many unhealthy wells. If I lose, let's say, 10 of them, is okay. But the healthy one, I cannot really jeopardize its production. So they go and facilitate it with all the equipment and monitoring capabilities to make sure it sustains its production. And maybe there are few of them, those big giant producers.
Yeah.
Um, and maybe there are too many of the small producers. So it depends. But if there are, let's say, hundreds of wells that are very low producers, you have to calculate basically uh, what kind you have to know technologies, what technologies you will basically implement to make sure You monitor these wells, and to sustain, I mean, you want to sustain their production. So it goes into the investment. We show this. We shown the sphere. The sphere is the biggest, and the biggest is technology as an investment. And
Yes.
you need to put it in a place where it gets you the return. Otherwise, it's just like unless it is very strategic and you would like to monitor all the wells all the time, and you have all the money to instrument all the wells, which is not really the case in many of the companies.
Yes, sir. And so my take from this discussion was that yes, if you are able to get results from whatever you are designing, and so companies won't hesitate to fund that. So and
And it depends on the process itself.
yes,
Let's assume
yes,
that it's reservoir management. Do you really need subsurface gauge in every single well for
um,
low rate producers? And maybe not.
yeah,
Let's say you have H2S, and that's more of health and safety. Do you need a gauge at surface just in case of a leak and a closer to a residential area, for instance, so you prevent people, prevent H2S, or at least you get an alert that's quick enough. So it depends. Every scenario has its own, objectives and challenges. Or, let's assume you have these wells close to a residential area. You have H2S in these wells, which is really dangerous. Would you install H2S detectors?
yeah. If it's necessary, only then yes.
Maybe yes. Definitely yes. And you will need to educate not only now it's not only the detectors and technology. You will be having a program to educate people in what they do and how they practice safety. And you have to do refreshers maybe to them. Yeah, so you teach the community, because again, they will be the ones who are impacted if, God forbid, one of these wells leak and the wind is towards their direction to the residential. So it depends. It's not only one thing. It's a program.
Yes, sir, I
It's not
understand
only
this.
technology.
Yeah. Yes, and we are getting so many questions, and I know I promised you only 1.5 hour session, so I have to skip to most of the questions, and I think people are really enjoying this session. Thank you so much, sir. And so I'd like to ask you one last technical questions that this digitization, will this help the oil and gas industry to sustain for more years, or will this lead to a quick shift from oil and gas to renewable sector?
Well, shifting is a different shifting to different energy is different from sustaining basically oil and gas. It's two different questions here. But sustaining, definitely, uh, based on the leaders, and again, the leaders slide that I showed, big companies, international companies, national oil companies, have invested on digitalization and technologies to meet their objectives or to optimize certain things. Definitely, they see value of it, and definitely, they will improve in bringing uh, either more oil, sustaining production, and extending the life of the wells and the equipment. So the first answer is, I think, yes. If it is used, so you don't just deploy technologies and don't use them. Deploy
Yeah.
technologies, capitalize on their capabilities, use them the best way possible for whatever you intended to. I think then they'll produce value, and they
Yeah.
will extend the life of the field or a well or the equipment. Now, when it comes to the alternative, is a different issue, and that's more. It goes into policymakers and investments and other things. So it's not really. Oil will remain for a long time be it used for energy for transportation and other things. So basically, oil is used in many aspects beyond basically the energy that we conventionally talk about.
Oh, yes. Yes. True, sir.
It's not only energy.
Yeah. Yes, sir. So, yeah, we had a really good discussion, but now I would like to conclude and just ask for your opinion. And as a membership chairperson for our student chapter, I feel that students are not actually using the SP resources very judiciously. So, I want a message from you to our viewers that how to use these resources and the resources of DETS and other technical sections to enhance their knowledge, and please give a concluding message to our students or our viewers how to prepare themselves for what change will be happening in the oil and gas industry.
Well, to get to know what's happening, we must be really, we must attend to seminars, maybe meet with people who have seen things and experienced them. And they're basically I wouldn't say the older generation, the wiser generation, but definitely joining technical sections, attending webinars, and these days are many webinars everywhere about many aspects, in fact, in life. It doesn't have to be the energy sector. Panels are the best thing to attend to, in my opinion. Attending or participating in discussion groups, just like the ones within the SPE, there is a place called SPE Connect. And in SPE Connect, you may raise your questions, and experts will basically exchange and discuss that question or discussion. I think students have access to read, maybe not post, but again, LinkedIn is available to almost everyone. Get engaged, expand your network, pick who you connect with, because basically, don't waste your time. I mean, and discuss ideas. We said great minds discuss ideas. Discuss ideas. And seek ideas. And maybe be silent for a while. Get to know what you want and what your desires, and you have to know your qualification, what exactly you're best at, and just improve that thing.
Yes, sir.
So everyone has an edge and has some sort of talents, and definitely it can explode, but it needs patience, passion, and but more than patience and passion, efforts. So exert more efforts, read more.
Yes, sir. Yes, and I believe, I wish our viewers also believe that this session was as fruitful and as interesting that I find. And thank you so much, sir. I can't stress this more. Thank you so much for sharing everything that you said. It's just really good to attend. I'm hosting this event, and I hope our viewers could get something good out of this, and they'll apply those in their future lives. Thank you so much, sir. And
thank you, Anish, and the thanks extends to the whole chapter for basically organizing this event. And I hope I answered the questions.
yes,
I'm available at LinkedIn, and I usually give feedback whenever I have time to questions. We have a discussion group even in LinkedIn about digital energy, where people can basically connect to and participate in, and try to formulate and articulate your question in a way that's more of a specific, so the respected readers and members can at least help you in answering the question, and maybe lead you to where they are, or lead you basically to the answers.
yes. Thank you, sir. And I'll be mentioning that link to in the comment also after the stream ends. So to all our viewers, we again thank Mr. Saeed for this fruitful discussion with us, and I urge our viewers to subscribe our channel and follow us on our social media platforms just so that you can get updates of our next sessions. And I think you'll be more interested now that we have presented you our first session. Now you'll be attending in great numbers. So thank you for watching. Thank you for attending. Thank you for staying with us till the end. And we'll meet you in the next session. Thank you. Thank you, sir.
Thank you very much.
Yes.